My name is Luijten, and today I have an honor to hosting this esteemed panel of specialists. We'll tell you more about the topic, minimize energy use, optimize crop results with the use of smart lighting. Today, we have the privilege of hearing from these experts in the field who will share their insights, experiences and research findings on the remarkable potential of smart lighting in horticulture. We will explore topics such as the effects of DLI controllers and zoning, field experience of retrofitting from HPS to LED lightings, and also research results on far-red dimming lights. If you have any questions, feel free to ask your questions after the presentation during the Q&A. Let me introduce you to our first speaker. It's an honor to have you here, Leo Marcelis. Leo is Professor Horticulture and Product Physiology at the Wageningen University. He will explain more about the effects of far red for the crop and fluctuating energy prices. Feel free to join us on stage.
Okay. Thanks a lot, Angela. Can I stand
welcome.
here? Good. Nice to see all your people here. I see quite some familiar faces. That's maybe going a bit too fast. I will try to tell a little bit about energy saving. And it's just, I have only 10 minutes and somewhere there's a clock. Yeah, I see now also the clock. So I have not so many results that I show, but at least a few points that I also can further have the discussion. I think the microphone is going up and down, isn't it?
Yes, I had the same problem.
Okay, good. I will try to adapt my voice on. Oh, it's very, very, very different. Okay, I hope you can hear me. Good. Lighting. Well, what is smart lighting? Smart lighting is a lot. We can do it in many different ways, and it is just a nice word. But what we have to do is we have to look at the crop, because first of all, we use the lamps. I really think it needs to be different. I guess this is better. I hope. I will try. So with light, it's very important for the crop, for a good yield, for a good quality, but of course it comes at a cost of electricity. Energy prices are high, so we need to use it efficient. I would say, first of all, let's look at how efficient is a plant using the light. And maybe when prices were initially not so high, and also what we see in research where it started all on constant levels and a constant spectrum and a constant intensity throughout the day, from day to day, everywhere the same. But plants are not constant. We need to look at the efficiency of the plant and use the light when it can be used more efficient. Apart from the plants, there's also the electricity price, which is rapidly or can rapidly fluctuate. So we have to take that into account. So first in my talk I will tell a little bit about that, and in particular I hope that that leads to some further discussion for the panel. And I will say a little bit about choice of spectrum. Choice of spectrum, I could talk the whole day. I only brought here just one example of far red. So give light less when it uses it less efficiency. But how do we know if the plant is using it efficient or not? So we have to monitor the plant activity. So that's one aspect. And how can we do it? Well, then for instance, fluorescence sensor. Well, what is that? Well, those sensors are available. And I think more and more we have to look at the efficiency of plants, how to adapt the light intensity to that. If you don't have this sensor, well, you can look at the plant how efficient it is, but it doesn't work in that way. Looking at the plant anyhow is always good, but from moment to moment, it's difficult. A simple one is just adapt already the intensity of the lamps to the solar radiation. Well, then you can do it in a very simple way. You can do it in a very sophisticated way. You could say, well, make the LED light in what you see here. The intensity that you apply, making it depending on the solar light intensity, that's already what standard is done. Where the growth, well, when the radiation is above 200 or 400 watts per square meter solar radiation, we turn off. But we can also do it gradually. And instead of the light intensity, we could make it based on the plant activity. And apart from that, we have to look at the momentarily value, but also on what it leads to a value of the whole day. And then we can discuss further whether you need to do a level per day, or per 2 days, or per week, or per 2 weeks. And I think there's a lot to gain by that, by adapting it to the efficiency that the plant can use. Then the next step is, that's what I try to indicate here on this slide, is that the electricity price fluctuates very rapidly. It is we have seen it now in the past years, but what I want to say in particular, what I'm interested in is...
2 seconds.
Okay, I hope this is better. Do you hear me? No, you don't hear anything. If I talk loud, then you hear me? Good. I know. Oh, now we did. So electricity, we have seen the electricity prices from year to year. It can vary, but what I'm most interested, well, not most interested, but where we can adapt to also is on within a day it can vary, from day to day or from week to week, and how to adapt to it. So we have to look both at the efficiency of the plant and the electricity costs. And those electricity costs will be more variable in the coming years, because more and more there will be sustainable energy, sustainable electricity, renewable. That's good. By wind, by solar panels. So what makes it? If there's a lot of sun and a lot of wind, you can even get money by using electricity. And at another moment, in particular on the dull days with not much wind, it will be very expensive. So how to adapt it? And then we get all type of questions on what is the flexibility of the crop and how long period can we integrate? Well, I can tell you, that is definitely some of the research questions that we get every day and where we are trying to work on, and I'm happy to discuss about that. Also looking at the time, from that I want to, with respect to spectrum, I want to show you just few examples. This is far red, so far red light, which is, well, you could say dark red. We hardly see it by our human eye. Traditionally, it's not considered to be photosynthetic active. We know now already more that it also can drive photosynthesis. This is an example of lettuce on the left-hand side, where you see plants grown with 150 micromole red-blue light, and on the right-hand side, when there is some far red added. Quite a big effect, and here you see then in numbers. So this was an experiment, as I said, with lettuce. Plants were grown at 3 different densities. And then we calculated the radiation use efficiency. So that radiation use efficiency is the gram of plant that we got per mole of radiation. There's the total of the PRR, par level, and the far red together. Well, then you see the white bars and the red bars. With far red, the radiation use efficiency is higher. So this is very good for the lettuce. A few examples of tomato, already some older research. But this is what you see in most plants. If you go from left to right where you add far red, in young plants you get a more stretching, larger leaves. And because they form larger leaves, they intercept more light, you get more growth. But at the right-hand side, you see only when it is 15 minutes at the end of the day. That has already also quite some effect. And that's energy efficient, because that's only a short moment, a little bit of light. Here an experiment in tomato. The Young Ranyi is the one who did this research, and this is just one of the examples of experiments that were done on tomato. If you add far red, you make them more generative, relatively more fruits. That can lead to big yield increases. But there is a downside on it. Maybe you make the plant more generative, but you may make it too generative. So far red, and that holds in general for far red, you can do it too long periods, too many days. It depends on the stage of the crop. It depends on the status of the plant. Use it as a button. Use it as, for tomato growers, they are continuously, every day they're looking at the crop. Is it generative or vegetative? Do we need to take a generative action or vegetative? Far red is a generative action in tomato. Use it like that. A lot of details, and I see that I should speed up. So, very brief, what does far red do? In general, it gives more leaf expansion, therefore more light inception, more growth. But you get also taller plants. Sometimes you like it, in many cases you don't like it if it is longer. There's some photosynthesis, but the key message that I want to give, far red, I see a lot of advantage in many crops, but not always. Control it separately. It's a button, it's a tool for the growers to use. And then in general, plants are not constant, climate is not constant, energy price is not constant, so use the lamps dynamically. Thank you for your attention.
Thank you so much, Leo. Thank you. Now we will put it into practice with our next speaker of today, Kurt Hendrik Sandvad, Production and Sourcing Director at Tropica Aquarium Plants. Kurt will explain more about his experiences with growing aquarium plants and his transition from HBS to LED lights. A warm welcome to Kurt.
Thanks a lot, and thank you for inviting me here. It's a pleasure to be here. Yeah, I'm going to talk a bit about how we use it in practice, trial in practice. This is the world I come from, aquarium plants, tropical aquarium plants, which we grow in far up north in Denmark. It may seem a little exotic, the way we to use aquarium plants here, and what's the connection with the conversion from HPS to LED, but actually there's a lot of similarities in growing aquarium plants from other ornamental crops, but I'll tell you a little bit about that. Just to give you a brief introduction where I come from, this is Tropica in Denmark. It's in the western part of Denmark. Our company consists of around 10,000 square meters of greenhouse, traditional greenhouses. We have a laboratory as well, and a tissue culture laboratory where we grow many of our plants for our greenhouse production. And then, of course, we have administration building as well. The tissue culture laboratory we have used for many years for the production of our plants. We found out that these way of producing plants were very good for us. We get very uniform, good quality products in this way, and that was why we're using this and have done for many years. So we had already, from the tissue culture laboratory, experience in using LED lights, but we didn't do that in the greenhouse production. From the tissue culture laboratory, we sell some plants directly from the laboratory, directly to the end users in small cups like these as you see here. But many of the plants that we produce in the laboratory are passed to the greenhouse for further production to bigger aquarium plants. You may think that growing aquarium plants is in big tanks and so on, but it's not really. We actually produce it like, well, any other plants that you can think of, ornamental plants, in this way here, in traditional tables in greenhouses. And this is how our production looks like. This is a different kind of plants product we have. The standard is this 5.5 centimeter pot of different varieties. We have about more than 100 different varieties. We usually brag about that we are the world's leading producer and seller of aquarium plants, and in this way we need to have the complete assortment that an end user can use for their tanks. So this is the standard product, but we also grow plants on decoration items here, like a driftwood, a lava rock, or a cocoa shell, and the different varieties and different types. So just a brief introduction. Also want to tell that this improving our production, our processes and facilities have been an issue for us all the time. We need to develop, to stay in business, to move forward. So that's what our focus has been. And also in the recent years, we have looked more into trying to grow things more in a more sustainable way and try to develop different projects where we are looking at, for instance, these 4 UN goals as a guideline for us in the development of our production and projects in the company. Okay, so what we are actually looking at here is that we had a power challenge or electricity challenge here in August last year. We had a new peak season coming up. At the same time, due to the situation in Europe and in the world about the increasing disturbance in the economy, increasing prices, so on, we're really facing a huge increase in all our production materials, and especially the energy prices were going crazy. We didn't really know how it will end, but at that time we were really looking at ourselves saying, okay, what's going to happen here? So we said, yeah, we need to do something because we can't really manage these high energy costs. So we need to do something dramatic to lower our consumption in our company in general. To understand why is I have this presentation here. Our sales volume per month. We have a fiscal year, budget year going from May to April, and we are having our peak season in October, November, December, January. These very low light month. Aquarium plants is a hobby for people when they stay indoor, and they stay more indoor, of course, in the winter time. So this is our sales volume that we need for our production. If you combine this with the sun hours in our location in Denmark, then you see it goes directly the other way. So we are really not having a lot of help from above when we look into light intensity in this month of the year. So that was, of course, a challenge for us. If you look at the prices, now Leo mentioned the prices are fluctuating. When we look 2 years back here in this curve, I can see that we have a firm price here in 2021 on a firm contract. So that was easy and a very low price as well. We were not able to continue with a permanent contract, so we were out on the spot markets, and that's what happened here. Firm contract out in the spot market. That was August last year, where we were facing an 8 to 9 times increase in our power costs. That was, of course, a challenge for us. So we needed to do something. We have a total power consumption at Tropica in our big company, laboratory, production area, administration, everything, of 2.2 million kilowatt hours per year. We had a goal saying we would like to aim for a reduction about 30% so that we can lower our consumption to 1.5 million. That will really help us a lot in these challenges about the prices. The tools that we were looking at was, of course, to have more attention on it. When we have such a low price on energy, you kind of saying, well, it doesn't really matter, we can just turn on the lights and then you go along. But now we really have to pay attention to all our machinery, automation thing that used power to say, what can we do? Can we change strategy? Can we turn out the lights a little later? Can we turn off light that we don't really use? Can we do something about the machinery, the equipment that we have? But we also said that we can't really save all these things without making some investment. So that was also a clear decision saying, yes, we would like to make some investment to handle this in the future. The power consumption for our growth light alone in the greenhouse area was 750,000 kilowatt hours per year. So that is quite a lot also with the increased prices. So we decided to make a complete conversion of our HPS, high pressure sodium lamps, to LED. And that was, well, a little risk to take because we didn't really do a test first. We just say, okay, we'll do it, because we were a little afraid that we will run into problems with all these high prices of the power. So we said, let's do it, and let's do it completely. Of course, we were looking at the different things that we needed for this. First of all, we would like to have the same light level as we had before with our HPS lamps. These are 80 to 120 micromoles per square meters. We would also like to have the same growth of the plants. We grow a very nice crop in general, so this excellent performance of our plants we like to maintain with the LED lights. Also, the what I call light experience here is that we did some tests before with red lights, far red light, and so on, and it was not really good working conditions for our staff when they were working in an area where we need to pack or monitor plant growth or pest or disease in these red light environments. So we would like a more clear or white light to work with. We would like power savings of around 30-40% as a minimum to make the conversion. And of course, the purchase price of the LED units we're looking for was also very, very important for us. And also with the time for how fast they could grow the supplier, how fast could they install the lamps, because as you see from the curve, we were really high in August and we didn't know was going to continue in a very high level or was going to drop. We didn't know anything about it. So delivery time was very important for us as well. Okay, the chosen solution we had was a meter bellatrix lamp solution from Heliospectra. We had a couple of different options, and we chose this one because they had all these requirements that we asked for about delivery time, price, everything. So that was the one that we go with. We installed the things here, or the lamps here in November and December last year. So it's really new. So it was in the middle of our growth peak season. So I don't have only for a part of the result for part of the season. But I have results. We had this goal of saving 30% of our power consumption in total for the complete company, and we were actually able to realize 32% reduction. So that was pretty good, and we were of course satisfied about this. This is the power consumption when you look at it through the year, from 1st of May last year until 1st of May this year. The blue columns here represent 1 day of power consumption in our company. And as you can see, we have a peak from October here until March, where we have the growth light in the greenhouse. The blue color here, the blue column here, is this year or the present previous season, and the gray column behind are last year. So you can really see the difference in switching over from HPS here in this light season to LED. That's really satisfying for me to see this way. If you look at the power consumption for the production alone, looking 2 years back, you can see it here is the blue column are the for 21-22 season, and the orange one is for the previous season here in the high intensity month in December, January, and February. And as you can see, more than 50% savings on these on the consumption of this period of time. So of course, very satisfying. So we need this 30-40%, as mentioned before, for our growth lights, and we were able to say yes, around 40, because beside this lamp alone, we did a lot of other things, changing strategy and so on. So I can't really put all the credit on the lamps, but we did a lot of other things as well. But at least 40% comes from the conversion from the HPS to LED. And the main elements is, of course, yes, less power consumption from the LED units themselves, but also due to the flexibility of the unit. With the units that we have bought, we are more or less possible for us to make individual strategy per lamp. So that's really good for us, so we can dim the lamps up and down to increase growth or to decrease growth, depending on our needs for our production. So that's really good. So the learnings from this LED conversion, power savings of around 40% as from this conversion. We maintained actually the quality of the plants, so that was also, of course, a key factor for us. It would have been no use for us if we had a very low, poor quality and saved the money, so it has to go together. We had a higher heating cost because from the HPS lamps we have a lot heat generated from these, and we don't have the same heat from this, so we need to increase our cost from our gas from our normal heating pipes. But it's around 15%, and it's pretty okay compared to what we expected from this. We also realized that we needed more man hours to make this strategy and controlling everything. But I think that it's paid off that we do this and to help and to maintain a good flexible system so that we can save the energy. And last of all, I think there's a huge potential in the future for this. Also, when you look into light management in general, using daylight integral to general growth control. We don't grow plants on contracts at Tropica, so we are more or less dependent on our estimates of what we can sell. So sometimes it's good to slow down growth a little bit, and sometimes it's good to turn up depending on demand from our customer. So that's really helpful. Also, the things about having the use of weather forecast and price for the power, for the electricity, is very good to make it into an integrated system. I think we have a lot of learning to do still to be able to manage it, but I think there's a really huge potential in using this in practice. That's all from me for now.
Thank you so much, Kurt.
Okay.
I think everyone wants to switch from HPS to LED now, and that brings us to the next speaker from Heliospectra, Rebecca Nordin,
Thank you.
their CEO. So your floor is yours.
Thank you. Hope everyone hear me good. I thought I'd do a small introduction. There you go.
Yes.
Okay. Now, small introduction to Heliospectra. We are a publicly noted company. We have been active since 2006, started with our roots within research. So we have done extensive research when it comes to LED and lighting. Our main focus is smart lighting solutions. So since the beginning, we have been looking at not only light, but also on how can we tweak, how can we look at different lighting strategies and adding the control to growers. So we've been looking at sensors, algorithm, and how to optimize the light environment, and looking at both how to maximize the energy savings for growers compared to traditional lighting installations. We're looking at energy efficient LED lights. We're looking at how to zone and control your environment and how to integrate algorithm and DLI control into the facility for growers to save energy. The second part we're focusing in is, of course, the optimizing plant growth. I mean, in the end, the quality of our plant is super important. That's what we're living for. So we want to have a targeted spectra for the crop and the plant that you're growing, of course. We want to, and part of what we are supplying is also a flexible solution with a flexible far red, for example, but also looking at optimizing that for different varieties or stages in your growth facility. So I thought I'll go over some of the more in-depth tools that we have and how we are using smart and control in your different growth facilities, basically. So one of the tools that we are having is, of course, having a controllable fixture. Sometimes it's not just one light that is optimal throughout the growth cycle. Sometimes it could be good to have different light strategies throughout the growth cycle, or to be able to trigger, for example, the vegetative stage or controlling the generative stage of your crop, of course. Therefore, we are supplying, for example, a flexible light where you can do both par and far red, but then also do different strategies and applications with only far red, for example, in the end. Another tool that we find is super important for growers and not always used to full extent is optimizing your light environments using growth zones. So looking at your greenhouse is often you don't have one single greenhouse, one area. You can control it by different zones. You can have different varieties. It could be different stages of your growth. There could be different crop strategies or light intensities that you want to set throughout the growth environments. So I thought I'd give you one example. So for example, if you're looking at optimizing your environment, if you're looking at zone 3 here as an example, where we have a total DLI, that is daily light integral or total light during a day for a crop. If you set the goal there by 14.8 DLI, which it would be a supplemental DLI of 5.8 from the light, and you roll that out into your greenhouse and your grow facility. If you're looking at zone 1 and zone 2, and this is based on a trial we did in SLU, you see a huge difference both on the energy consumption, but also how much light that is used within the different zones. So you see a 7% and a 12% diff when it comes to how much light you're using in zone 1 and zone 2. But you also see then that there's a big difference in the power consumption, of course, within those zones. So you're actually using more energy and more light in zone 1 and 2 than you would actually be needing to use, basically. So there is huge saving by optimizing to the different stages or parts and zones of your greenhouse. Another thing that we're looking at when it comes to dynamic dimming control, or this DLI controller. So when we are talking about our DLI controller, what we are using is, of course, we use our power sensor. So we're registering the natural daylight that comes into your growth facility. We're also taking into considering the weather forecast. We're looking at the different energy prices that you have that you could enter as well. And you're also looking at the efficacy, actually, and optimizing the efficacy of your lights. Because if you're, for example, if you're dimming your light, you increases the efficacy levels of the product as well. So we take a lot of different things into consideration and using the algorithm to optimize the light level to use a stable yield throughout the year with a good quality, but also for a minimum energy consumption. So if you look at this, this is an example of how we're using the DLI. But basically, the main goal is to optimize DLI throughout the year to give that even. You save the energy by avoiding, basically, using the lights when you don't need to use the lights. You're stabilizing your yield that way because you're having an even climate. And you're also getting another feedback later that I will take a look at, but also feedback from the plants, which would be the next step of this. So I'll give you a quick example because I know the time is running out. But here we have an example of a butterhead lettuce in Vancouver. We're looking at a photo period of 18 hours, PPFD of 300 as a goal. We're comparing two different settings in your greenhouse. So we do a threshold control and we do a DLI controller. So the threshold control has a 200 goal, 200 PPFD. And the DLI controller has a DLI of 17 throughout the day, with a threshold between 60 as a minimum and 500 as a top. So if we're looking at the two different examples, so if we're looking at the on and off threshold, you can clearly see here during the day how it's optimizing. So if once it reaches the 300, it basically shuts the light off. And then when when it reaches 200 micromoles, it shuts the lights off. And also in the afternoon, when you see the light levels go down, it goes on again. If you compare this to the DLI controller instead, when you take into considering also, for example, prices, you're optimizing light throughout the day, you see that there is a difference in how the light and how the DLI or the LED lights are used throughout the day, basically, to optimize and see not only on how are we at the light levels, but also when is the most optimal time of using the LED lights. So if we only look at the sun levels throughout this case, you see that there's underlighting most of the days throughout these October-November days. If we're then adding the reference with the on and off threshold, we see that most of the days within this time span, we're actually overlighting because of just switching on and off. So we're using the lights more than we actually need to in the system. If we're then looking at instead integrating sensors and where we are reading and we are actively working throughout the day with it, we can maintain an even DLI target throughout the day of 17. So it's a quite significantly less use of light throughout the day. And if we're looking at it and summarizing it, it's actually 42% less than if you just use the threshold control on the light intensity targets. And if you compare that to the total DLI, you realize that you're actually using more DLI on the threshold control than you do to the set target that you have of 17. So there's a 27% difference there. Two other further cost savings, I'm going to speed up a little bit, but it's to use the electricity optimization, because if you add that as an example and you're avoiding the peak hours within your facility, you can actually save another 7%, because then you're spreading out the light instead on those hours where it's cheapest to use it compared to the more expensive and more just targeted throughout the light levels, basically. There is also another further optimization that you can look into. And as I mentioned previously, if you're looking at the efficacy of a product or a LED light, if you run it at a 100% or if you run it and dim it down, you're actually increasing the efficacy of the LED light. So if you implement this as well into the algorithm when you are targeting and you're planning the light levels in your greenhouse, there is an actually additional savings of up to 5% in how you can plan it and what you could save in your room. So here's just some examples of how we have used the electricity price optimization. But here you can clearly see that when you have the typically high peak hours of the electricity prices, then you see that the lights are choosing not to use the LED lights during these sessions. So it's actively turning it off to save energy and save cost for the growers. Here is another one when we're using and looking at the lamp dimming efficacy, for example. But here we are using the same DLI, but over a longer time span. So we're dimming it down instead of using maximum output, thereby also increasing the efficacy of the lights. But we're still getting the same DLI, but we're doing it more energy efficient, basically. And I just want to run off on where we see it as the next stage of LED lights. Like, how do we take the next step? Because a lot of the things and examples that I've provided so far is around energy efficiency and optimization in your greenhouse, how to reduce cost. But it's also very important to look at the plant growth efficacy and how to optimize plant growth, right? And one of the next steps that we are looking into and what we are optimizing is we're looking at fluorescence sensors and what we call our biofeedback sensor. So we're looking at then at basically reading the lights in terms of how to identify the optimal light levels. Where is the stress? When has the plant actually had enough? And optimize the light after that. We're also looking at, for example, if the plants are stressed because they are lacking water or nutrients, but detecting different stress signals to find issues before they are happening to save money and, of course, time for the growers. We're also looking at growth tracking. So there is the possibility of tracking growth and see where are we. Do we need to supplement with something? Do we need to change the light strategy for the crop? But how do we optimize and make sure we're on track kind of throughout the growth cycles? Making sure everything flows and making you able to plan your production and your yield in the future. And these are some of the 3 different steps that we are looking into in the future, and we see as a natural part and the next step of where LED lights are heading in the future. So, thank you.
Thank you. Oh, wonderful to hear about the new innovations. We have some minutes left, so we want to do a Q&A. I am searching for a mic. It's over there. I'm going to pick it up. Thank you. Does anyone has a question for the audience? Yes, please. Please introduce yourself.
My name is Louis Broekhuizen. I work for Blue Radix, one of the AI suppliers.
Yes.
And I've got a question for Mr. Kurt Sandvad. At the end of your talk, you mentioned that because of you using less electricity for the new light systems, you need more heat. And I wonder, what is your energy source for heat?
It's gas.
Gas.
Yeah.
Are you using a CHP, a combined heat and power unit, or just a boiler?
It's the LPG gas with a heater.
Thank you.
Okay, welcome.
Thank you for your question. Any other questions? Yes. City Farm.
Yes, hello. I also have a question for Kurt. My question is converting to LEDs. What's the payback period? Because you said, for example, you save 30% or like 40% on energy per year. In how much time your investment is paid back? Could you share that? Yeah.
Actually, less than a year.
Less than a year.
Yeah.
Okay.
Everyone wants to invest now. You are popular, Kurt. Any other questions? Yes. Sweet Green.
Hello, Joachim from Sweetgreen. I have a question maybe to Leo about light strategies. We heard that you could dim the lights during high energy price costs. If you want to apply a light strategy and turn off lights, we have to mention that we only use artificial lighting. What happens with a plant? How does it react if you turn it on and off like two times a day? Does it, if you only apply the DLI that it needs with a certain on and off periods, what's the strategy here? And should you also then put it on like 100% at, or should you ramp it up and ramp it down to simulate the sun? What kind of strategies should you use to optimize plant growth?
Very important question. Always put the plant in the spotlight.
Yes. Yeah, I think it's a very good question. And I cannot give a very concrete answer because this is, I think, where now all the questions are about how flexible is the plant. I would never do immediately turning on from 0 to 100%. At least I would do it gradually in a few steps. Not necessarily like the sun is doing, but at least not, well, probably anyway on the energy grid of your whole system. It's probably not wise to have them all on at the same time, but also for the plants. Plants respond quite rapidly, but it may also take 5, 10 minutes, 15 minutes. So I would do it in a few steps going up. Then the question is, how flexible is the plant? Can we have 1 hour without light, 1 hour with light? Well, I think DLI is the most important one. So that's a major effect. On top of that, we get maybe some smaller effects of how rapidly on off. That's also, I think, well, we have not so much experience yet on that because so far we did not pay too much attention to it. Another point that you have with those type of systems that you have to think about is what is the night period? And for me, a night is, let's say, a dark period. Some plants can grow quite well with 24-hour lights. Many plants don't like 24-hour lights. And for those plants that do not like 24-hour lights, we have to think in particular in the night period, an uninterrupted night period. So most plants, many plants want at least 4 or 6 hours of a dark period. And on that period, I would not turn on the lamps. But beyond that, I think the major issue is, let's say, that you look at the DLI on the effects and energy price. So there's quite some flexibility, but don't make it too extreme.
We have time for one last question. So, anyone with a very important question? Yes? I'm coming to you. You're welcome.
Hi, I'm Chao. Maybe it's not a very important question, but we all know the spectrums also have a great influence on the plants. And if we're trying to dimming the spectrum, it will also adding cost on the fixtures. Do you believe in the futures dynamic spectrums is necessary to putting on the fixture functions, or it cannot compensate the extra cost?
I could say a little bit about what to expect from a plant size. With cost and a look at
general question.
So in general, one point that I made, I think with far red, I think I see a lot of advantages, but not if you have it, use it continuously. So I think for far red, if you want to work with far red, I always would recommend to have that control separately. With respect to the other colors, I think more and more we go towards dynamic light. But if you now ask me, so also a dynamic spectrum, but we are still there at the start. So practical recommendations for this dynamic spectrum is hard to give. We will learn in the coming years. For far red, I quite assume that if it is controlled separately, that it is cost benefit, but I don't know what the costs are. And I guess you want to. I'm not sure if you want to.
Well, without going into details on prices and costs, but I think the add up today for a dynamic light, especially if you're looking at kind of the more maybe economical flex solutions compared to fully controllable lights, it depends always on also who is the grower and what do you actually need in your grow facility. But I think at looking at dynamic lighting today is very achievable. I think the benefits, especially for some varieties and some crops, You see big benefits basically of, for example, adding far red to the different light strategies. We see a lot of crops using maybe shaving off days of production when they do end-of-day treatments with far red to add on, or the ability to add on, for example, far red to improve the quality of the crop production during winter months. So having a light where you can use maybe a par spectrum without far red during summer months, or kind of not when it's turned off, but in the shoulder months in the beginning where you don't need the far red, you don't want to stretch the plant. But during winter months and when it gets really dark, you still need far red to improve or have the quality year-round production. So I think with the added on quality that you would get from those types of fixtures, as well as some of the benefits of implementing a good light strategy, always, of course, crop dependent, because that would differ depending on crop and variety. But we see a big difference, I think, there. So it's very achievable, I think, today with doing more dynamic lighting and flexible solutions.
Thank you, Rebecca. We just came to the end of the session. So if you have any questions for the speakers, you can find them at the GreenTech. And I will thank the speakers for all their stories and insights they shared with us today. Thank you all.